Welcome to today's video on mastering probability in data mining. In this lecture, we'll explore key concepts like probability rules, conditional probability, and Bayes' rule, all essential tools in data science. Let's dive in. First, let's look at the outline. We'll start by understanding what probability is and why it's important. Next, we'll discuss how to use probability notation to express events and rules of probability to solve problems. Then, we'll explore the concept of conditional probability, how it works, and introduce Bayes' rule, a powerful tool in data science. Finally, we'll apply these concepts to real-world problems by the end of this video. You'll have a strong foundation to tackle probability-related challenges in data mining. Probability is a measure of uncertainty that ranges from 0, indicating an impossible event, to 1, indicating a certain event. Key concepts include random processes, which result in outcomes determined by chance, and sample spaces, which represent all possible outcomes of a process. Events are subsets of these outcomes, and their probability is calculated as the number of favorable outcomes divided by the total outcomes in the sample space. Now, let's discuss the fundamental rules of probability. These include non-negativity, meaning probabilities can never be negative, and the total probability rule, which states that the probability of the entire sample space is 1. For disjoint events, events that cannot happen simultaneously, the probability of their union is the sum of their individual probabilities. Additionally, the complement rule tells us that the probability of an event not occurring is 1 minus the probability of the event itself. In the next slide, we have an example of calculating the probability of an event. The code here demonstrates defining a sample space, selecting a subset of outcomes, and calculating the probability of that subset. It's a simple but practical way to understand how probability is determined in Python. Conditional probability measures the likelihood of one event occurring given that another event has occurred. It's calculated using the formula that states that the conditional probability of A given B is equal to the probability of A intersection B divided by the probability of B. Events are independent if the occurrence of one does not affect the other. In this case, the probability of A intersection B is simply equal to the product probability of A times the probability of B. This concept is crucial for analyzing data dependencies. This code snippet shows how to calculate conditional probabilities by dividing the joint probability of two events by the probability of the given event. This method is widely used in statistical modeling. Bayes' rule allows us to reverse conditional probabilities when direct computation isn't possible. It's especially useful in scenarios like diagnostic testing or spam detection, where we need to infer probabilities from indirect data. The formula is: the conditional probability of A given B is equal to the conditional probability of B given A, multiplied by the probability of A and divided by the probability of B. On the next slide, the code illustrates applying Bayes' rule in Python. It calculates the probability of an event given observed data, a common task in machine learning and decision-making applications. To summarize, probability helps quantify uncertainty and provides a foundation for making data-driven decisions. The rules of probability, conditional probability, and Bayes' rule are indispensable tools in data science, enabling us to model and analyze complex real-world scenarios. Python offers practical ways to compute probabilities and visualize outcomes, making it an essential skill for data scientists. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content on data science and technology. See you next time.